voor het tweede gedeelte van de dag, althans voor de TED Talks, de presentaties en de speeches. In dit geval beide heren vandaag van RISCOS Open. Vanochtend hebben we Steve Revel gehad. En als tweede vanmiddag Robert Sprousen, ook wel bekend als Sprout, ook wel bekend als Elazar. What else? Heel veel nicknames in ieder geval. Maar hij gaat jullie even op de hoogte houden van, hij gaat jullie op de hoogte brengen van de laatste stand van zaken sinds zijn presentatie van vorig jaar. Er zijn natuurlijk ontwikkelingen geweest. We gaan ook binnenkort hopelijk naar RISCOS 5.32, 5.32 in het najaar. Dus dan zal waarschijnlijk, dat is de hoop en het doel. En dan zullen ook waarschijnlijk nieuwe ROMs versterkt worden en nieuwe software voor alle platforms waar het op kan draaien. En we gaan een stukje in de toekomst kijken naar what else is nieuw. Het Moonshot-programma natuurlijk, de conversie naar 64 bits. Ik denk dat Steve vanochtend ook al een en ander over verteld heeft, want BBC Basic is natuurlijk ook een onderdeel ervan. En leuk om te vertellen is, Robert die heeft lineaaltjes meegenomen.
Rulers.
Ja, die heeft hij de afgelopen jaren ook mee gehad en ik snapte dat helemaal niet. Ik denk van, we zijn ook met software bezig, hoe moeten wij nou met die lineaal? Maar als je nou nadenkt dat Robert van rule is, en dit ook een rule is, alleen maar anders gespeld, dan snap je. Maar voor mij duurde dat het kost me 3 years to detect this. En het leuke van is, Robert die vertelde me, zijn physics docent, die zei van, als je nou een maatstaf hebt, in Engeland dan, ik weet, daar zijn ze een beetje gek, maar ik weet niet hoe dat die in Nederland is. Als je een maatstaf hebt die helemaal tot aan het randje gaat, dan noem je dat een rule. Heb je nou een centimeter of een meter waar zo'n kleine afstand zit, weet je wel, dan noem je het een ruler. And he got slapped by his physics teacher. That is wrong. So, ik vond het wel een heel leuk verhaal. Dus, maar goed, ik zal niet Robert in de weg staan. Geniet van zijn presentatie. Veel succes. Take it away.
Okay, thank you very much. I'd like to see you can see that.
Yeah.
Improve the contrast a bit. Yeah. Okay, good afternoon. Thank you for coming and listening to me talk about some things that RISCOS Open have been doing and will be doing in the future. So we're going to start with a bit of a recap of developments since I was last here in May, and some of the things that you might have missed on the Rule website, which might be of interest to you. So the basic reference manual you probably have seen on our stand. That was updated as a byproduct of some of the work that was being done on rewriting the interpreter in C. Now, unfortunately, we only bought, because they're quite heavy, we only bought the 3 copies with us today, so I'm afraid I've changed the line at the bottom to say that if you need a copy now, you can get the PDF from our website. So there were printed copies earlier. In fact, there's a picture. There we go. There's a picture of the front cover of the book. So yeah, that rolled in a lot of the corrections since the last edition in 2021. But I'm afraid, you have to get a PDF copy of that now. Related to books, and this was just more a way of joining my thoughts together, there's a bounty that's running at the moment to revise the programmer's reference manuals, which is a 6-volume set at the moment. So there's books 1 to 4 are the original ones that Acorn made. And then 5A came out with the RISC-PC, so that was RISCOS 3.6, had book 5A appended to the end of it. And so one of the aims of this bounty that's going on at the moment is to squash all the text back into one succession of books so that they're all in a more logical order rather than a time order. So when Acorn printed 5A, most of that was just, if you need to look up this thing, go and look somewhere else. And then they told you only the new things about the RISC-PC in that extra book. So we're trying to integrate those chapters back into the sensible order that they should have been in the past. And then another part of that, once that work has been done to put all the chapters back in the right order, is to extract the text that is used to produce the programmer's reference manuals and use those to fill in the missing pages on the Rule Wiki, because there's a wiki that you can edit with a lot of the programmer's reference manual in, but there are quite a few chapters that have been missed out of that. So it's not the exercise here isn't to combine all of the text from the wiki and the programmer's reference manual. It's to fill in the gaps in the wiki. So the wiki should then be a complete set as well. At the moment, I did do a quick page count. It's 3,900 pages, which is an awful lot of text if you were to read it from cover to cover. Available as 22 megabytes of PDFs, so 6 PDFs. What we're hoping to do, so once this bit of the bounty work is complete, the next step 2 of 2, is to fill in all of the missing material that happened post the RISC-PC. So that would be, for example, there's nothing covering how the USB system works at the moment. There's nothing covering how PCI works. And all of these things that you're relying on, SDFS, for example, that we've been using in the Raspberry Pi for the past 13 or 14 years, none of that's in the programmer's reference manual at the moment. So yeah, the idea is to hire a technical author, and the job there is essentially almost one of archaeology, because a lot of these things, there is no documentation. It's not that it wasn't put in the PRMs, it's just there was none written. So a lot of it is going to have to be going and looking through the source code, trying to figure out how it all works, why it was designed like that, and then writing the words that describe it so that someone can write it in the future. And best estimates are that's probably going to add, maybe another 800 pages, something like that. So if you divide that back down into books, you can get about 600 pages, comes out as a book about that big. So we think it's probably going to end up as an 8-book volume of programmers' reference manuals eventually, or an awful lot of PDFs instead. One of the other things that was rolled out, adding to the open source of SparkFS that David Pilling kindly did recently, is being able to rename within a zip file, which has been an annoyance of mine for many years, that you copy something into a zip and then realise you've put the wrong name, and the only way you can change the name is to copy it to another file and then delete the old file. So you can now directly rename inside a zip without having to do the copy and delete dance. It's also this point, the third point here, was someone had pointed out that if you install SparkFS on a new system that hasn't yet got a working boot sequence, or not got a working hard disk yet, you can't actually run SparkFS because it tries to look for the system directory. And there is no system directory because the hard disk is blank, and you end up with a paradox that you can't create the disk image because you can't unzip the contents, and you can't unzip the contents because you can't install SparkFS. So that has also been resolved. So if you run it on any RISCOS 5 system, it will no longer bother checking whether there's a hard disk there or not, which is quite handy. If you want to download that, it's available either via Pacman, or from the rule website directly, and there's also a self-extracting version of it. So you also solve the paradox if you don't yet have SparkFS and we were to deliver it as a zip file, you would not be able to open it. So it's all about the initial handling of the first time you ever need it. You can get the self-extracting version. That then gives you a version that you can open zip files with, which you can then create your hard disk with. So hopefully the sequence of events now makes much more sense. Now because it is open source, we've got lots of ideas for anyone who's a budding programmer who wants to add some extra features to it. There's some quite common compression formats out there that we don't currently support on RISCOS. bzip2 is a fairly common one. Deflate64 less so, RAR files and other archive formats. But bzip2, it would be really nice to be able to open those because they're certainly quite common in the things that I'm used to downloading. Encrypted zip files is also a possibility, so you can have password protection if you're sending someone your bank details in a zip file. You can password protect them. And then there's also the dream of being able to run them on one of the spare ARM cores that the Raspberry Pi has, for example, that's just sitting idling, because whenever you're doing a big compression job, the desktop sort of slows down while it's busy doing its compressing. It would be nice if you could get the compression to be done on one of those spare ARM cores and then leave the desktop to the other one. Lots of things to do if anyone here is a developer and fancies getting their feet into the SparkFS source code. Quick 1.5 slides on the DDE. So if ever you hear anyone talking about DDE issue numbers, it's reasonably simple. If there's a significant change, the first number goes up by 1, so 32 is the current major release. And then the letter part just goes through the alphabet A to Z if there's any little small fixes that come out. So generally, as long as you know that the major version number is the same as the one you're using, we'll be talking about the same thing. And so these were some things, examples of small changes. So these result in it going from A to B, B to C, C to D, and so on. Some little quality of life improvements for C programmers, adding extra warning suppression options. That's particularly useful. I find if you build something that's quite complicated and 300 warnings go past, I generally don't bother looking at any of them because there's 300. If I can get that down to 20 warnings, I probably will bother to read those and see what the compiler's trying to tell me. So having much more subtle ways of turning off some of the warnings helps you to get rid of some of the noise when you're compiling a large project, which hopefully will inspire you to look at what the warning is actually trying to tell you, because they often are important. And then related to CMHG, which is the C module header generator, if you're writing modules in C. There are some more veneer types that it can generate, and those are used when you're trying to jump from the assembler world of RISCOS into the C world. You need to shuffle which registers the results come in. Previously it was quite limited in the number of different veneers that it could generate, so there's now extra options to generate some of the stranger or the less commonly used veneers, and that's going to be important so that we can stop writing new assembler code and try and write things in a high-level language. And then the last point, so minor changes in the recent issue 32 of the DDE are some updates to the BBC Basic compiler, which is called ABC. And the main thing there was adding sys as a function keyword, and I'm hoping that Steve mentioned that when he was doing his talk earlier about, that's good, I'm seeing a nod. So that's the ability to read various internal state from the basic interpreter using equals sys, sys literally as a function, and also to convert SWI names into SWI numbers and SWI numbers back into names again. So those are the equivalent operations in the basic compiler that got added. And the last thing, which was last October, which was one of the larger changes, which resulted in the version number rolling over to 32, was adding a whole extra language, which is Fortran 77. And you might say, well, why Fortran 77? That's older than me. Yes, that's older than me. So that language came out before I was born. Now, it's surprisingly still commonly used, Fortran. I was quite surprised when I was doing some research before this talk. It's used in all sorts of climate modelling, where you've got particularly a lot of focus on mathematics and things, structures of atoms, those sorts of things, where again you're needing to deal with lots of angles and mathematics and trigonometry. So Fortran does get used surprisingly large number of places. But in the RISCOS world, you couldn't do that previously. So there is now a Fortran 77 compiler, and it uses the same calling standard as the C compiler. And so you can actually mix and match them. If there's a bit of your program that makes more sense to write in C because it's interacting with the window manager or something, you would write that bit in C. And then if you've got a really maths-intensive part in the middle, you could write that bit in Fortran, compile the two pieces and join them together, and it'll all just work out by magic because they're all based on the same calling standard, which is quite handy. So in principle, I think you could also write a module that was written in Fortran, although I haven't tried that myself. In principle, you could do. It comes with, because we love our manuals, it comes with a 200-page instruction manual, so lots of meat to explain how that all works. And if you get really stuck, there's also a support group who focus specifically on Fortran when running on RISCOS, and that's called Fortran Friends. It's run by a guy called David Crenell, who lives in Oxfordshire in the UK. So he also knows Fortran inside out. I think may have been his full-time job before he retired. So those were bringing you up to date on the things since I was here last May, or the main noteworthy things since last May. And we're going to have a quick look now at what might be coming forward in RISCOS 5.32, because we're due a stable release sometime now. Now, at the last show, I had a demonstration of how you could swap round the order of things on the icon bar, so that if you're a Windows user, you're probably more used to the applications being on the left-hand side and devices and drives go on the right-hand side, which is obviously the opposite way round to RISCOS. So if you're a newcomer to using RISCOS, that would be quite a shock to your system. So there is now a little tick box that you can select in the window manager setup to swap the icon bar round to be the Windows way round. Yeah, it's fine. If everyone here is very familiar with RISCOS, then that probably you would never turn that option on. But when we're trying to entice people over from using Windows, it helps to reduce the amount of shock they get if they see things that look a bit more like they were used to on Windows. And then if you've been looking at the stand today, we have a thing demonstrating the difference between a light mode desktop, where things are generally quite light grey or light coloured, and then the corresponding dark mode desktop, where all of your title bars and the icon bar and everything else, basically the colours get flipped round. So something where you would previously have had black text on a quite light background becomes lighter coloured text on a darker background. So if like Steve, you're used to using a computer for 22 hours a day without blinking, it reduces the wear and tear on your eyes if you're not having to stare at something that's quite so bright. There's a few bounties that should make the deadline for RISCOS 5.32. There's the last two features due in Paint, which has been rumbling on for a few stable releases. It's at the very final few steps of being able to edit alpha mask sprites, so sprites where it's not just a yes or no, is it see-through? You can have 256 scales of transparency. So at the moment you can view those in Paint, but you can't edit them. So being able to edit the mask is one of the last two features due to be added to Paint. And then the ability to undo and redo. So if you've accidentally splodged some paint in the wrong place in your drawing, you can undo as many steps as I think it's going to be proportional to the amount of RAM that you have. So if you make a large change to a large diagram, you don't get as many undo steps. It'll be something like that, I think. Second one, if you're into programming, you might need to use the Git source control client. So we've got a native Git client for managing source code. The only command that's left to do in that is the git rebase command, I believe. And that's what the little graphic over here is, showing a change history of someone working on a component, which looks like change FSI from my quick reading of it. And so this has three different views of any Git repository. The GUI view is the graphical user interface, is the one where you can browse each of the changes one step at a time. And then there's the command line view where you just type strange commands at the star prompt. And then there's also a filer view where each version in the history appears as a directory. So if you want to go back in time, you just go change directory to the one that's the earlier version. So it doesn't really matter which of the three you use. Personally, I prefer the GUI version. I can never be bothered typing much at the command line, but the options are there for all three. And the last thing down there is also on the stand, if Steve hasn't shown it to you, sharing his Windows 11 laptop hard disk using LambManFS. So that's being radically updated so that rather than it just being supporting SMB1, which is the version that's quite old, and generally Windows certainly is trying its best to withdraw that. It makes it very difficult if you want to enable it now. So by being able to support the newer SMB protocols, you can then share drives with an Apple Mac, you can share drives with Windows 11, you can share drives with Linux running Samba for things like if you have a networked hard disk, for example, they will often be running Linux under the bonnet. So lots of things going forwards there. And then outside of the stuff that the Bounty is concerning itself with, there's some low-level kernel work to add more accurate timers. So at the moment we can only measure things in hundredths of a second using the monotonic timer. So there's some work there to add nanosecond accurate. So that's 10 to the power of minus 9. Yeah, thank you. Yeah, microsecond is 10 to the minus 6. Yeah, so 10 to the minus 9. That sounds right. Accurate, much more accurate timing, and that's particularly useful if you need to do scheduling. For example, you don't want something that is working to a 1/100th of a second tick. That's actually quite a lot of CPU cycles now. And then some support in the C library to allow you to run vector floating point applications, and early indications are that gives you about a factor of 20 speed up. So anything that uses floating point, like draw, for example, you get of the order of a factor of 20 increase in speed, which is very nice. And then this section on improving the user experience for easier configuration relates back to what I was saying earlier, where we're swapping the icon bar round for people who want it to be the Windows way round. There's some other things where the first thing you do if you unpack a Raspberry Pi and put RISCOS on it is you think, oh, well, I've got this 16 gigabyte SD card, why have you only used 2 gigabytes of it? So having a facility to, on that first run, use up the spare space on the drive, for example, or automatically selecting whether you want to boot from the SD card or from a USB hard disk, those sorts of things. And I've noticed if you run Linux, the Linux version, Raspberry and Raspberry Pi OS, that also does the same thing. The first time you ever power that up, it says, which region are you in? Do you want your keyboard laid out for an American layout keyboard or a UK layout keyboard? So those are the sorts of questions. They're just, yes, no, move on, yes, no, move on, to try and make sure that you've set up most of RISCOS, most of how that person is expecting to see it, rather than booting to the default setup and then them being scared because they can't find, why does the right mouse button not do anything? Those sorts of things. And then ideally, and we'll come on to touch on the BBC Basic Interpreter later, it would be nice to be able to squeeze in the new the BBC Basic Interpreter as well. But I put that as a stretch goal because it's still quite a lot of work to be done, and we don't want that to hold up the next stable release too much. So this last section of my talk, you're glad to know I've got 6 minutes before I run out of time. It's to do with the Moonshot Initiative. And what is the Moonshot Initiative? Why are we thinking about it? Well, if you look at, this is a snapshot of ARM's website. These are all the processors that you can license from them if you want to make an application processor to run an operating system on. If I then cross out the ones that no longer have 32-bit mode, I only have 7 to choose from. So actually, we're already past the halfway point where I can't license only less than half of the processors that I could license to run RISCOS on don't actually run RISCOS anymore. So we're trying to address that, and there's a few options here. Of course, there's always several ways of solving a problem. The first one, of course, we could just do nothing and assume that RISCOS will be emulated in the future on a 64-bit processor rather than running directly on it. We could run RISCOS as an application on top of another operating system, so we could start with NetBSD or Linux or something and run it as an application, a bit like I would do. I've got some old design software that runs on Windows XP, so I run that in a window on top of Windows 10. So you could do a similar approach where RISCOS is forever just running in a window under an emulation system. There's a mixed mode where you run the operating system in 64-bit mode, but still run the applications in 32-bit mode. So that's particular to, there's an option, license option. If you go and speak to ARM, you can get it where the processor will run privileged mode code 64-bit, but you can still run application code 32-bit. our suspicion is that that license option will disappear quite quickly, and so that might be a useful stepping stone to help as a prototyping step, but it's probably not the long-term solution, because we'll just end up back in the same situation that it's no longer available as a license option. And then option 4 is kind of fully committing all in, where the operating system and the applications run in 64-bit mode. And then we would need some kind of Emulaw type system to run any of the old applications that couldn't be updated. And then there's a further sort of subdivision of that, which is the same as option 4, where you run the 64-bit OS and applications, but you limit yourself to not looking above 4 gigabytes in the memory map. So that's 2 to the power of 32. So in other words, all of the things that are to do with addresses stay as 32-bit, and everything else is 64-bit. And that's kind of the situation where we were when StrongArm came out. Yeah, I think it was Strong, where you could still run 26-bit applications in a 32-bit configuration. I think I've got the wording right there. So it's a similar idea to that ARM have given you a little bit of grace where you could just pretend the top half of the memory doesn't exist. But again, that may turn out to be a bit of a short-term solution. So the preferred option, and I guess the most future-proof one, is to try and make the OS 64-bit and to be able to run 64-bit applications, and then acknowledge that you need to run some of the older applications under emulation. So last year, and if you didn't look at it, there's a web address there. Last year there was an open letter from Steve, Managing Director of RISCOS Open, explaining this challenge in slightly more words. I only have 2 slides to cover it all in, so if you want to read the longer version of that, you can go to that website. And that resulted in a planning exercise where we were trying to work out, actually, if you hired a load of engineers to do all the work, how much work is there? So I think I showed these project plans last year. Basically, we looked through all of the modules, worked out roughly how large each module was, and if you were to hire an engineer to sit and convert that to the equivalent, and then you were to pay that engineer a normal salary or a normal UK salary, if you just multiply all those numbers together, you end up with around £2.5 million or €2.5 million, roughly the same exchange rate, to within the margin of error of the calculation. So yeah, it's a big piece of work, and if anyone ever says, "Oh, I'm going to do it this weekend," they probably haven't thought hard enough about what's actually involved. There's an awful lot of work involved. But you can make good progress. So, as with any problem that seems too big, the easiest way to tackle the problem is to split it into smaller pieces. So this diagram here has 7 blocks on it, and they're kind of arranged arbitrarily in time. So there's no reason why you couldn't take the emulation system and go and put it earlier on at the beginning. So it's only drawn at the end because sort of that logically made sense to do it in that order. But yes, you can move around each of the individual sections. So converting some of the core operating system modules is clearly a first useful task, because you can't boot a new system unless you've got some of those first few core modules. And then there's a big long list of, you saw on the previous spreadsheets, there's a big long list of about 80 or so, modules that at some point will need converting. You can get away without, RISCOS will run fine without most of those, so you can skip that piece of work until later. And then getting a kernel that will boot and that can display something on the screen, so it's always nice to be able to see what you're typing. And these are the blocks that, again, there's no reason why you couldn't change the VBU drivers, start that tomorrow afternoon. That's fine. It doesn't need to be 5th in the list. That's just an example ordering. And so there is a little bit of joined up thinking going on here. So I was trying to find the first set of presentation notes, and I think they were from 2017. That was the earliest ones I could find, where basically RISCOS Open is trying to say, please stop writing new components in assembler. That's our easiest way to stop making the problem worse, is to stop writing lots of new assembler. And by writing them in a higher level language, then obviously the exercise becomes when you want to move to a 64-bit system, you need to recompile the code, but you shouldn't need to change the code. That's the thinking. And so that's why, even back with Acorn times, they introduced OS caller SWI and SWIX, if they're functions that may or may not be familiar to you. And that was that the reason that Acorn wanted to do that was because they had a problem that you couldn't dynamically generate SWI dispatch anymore. So they needed a function that you could call in order to avoid the problem that there were separate instruction and data caches. So that then helps even now, as long as you have converted your program to use SWIX or use OS caller SWI, then that translates quite naturally to a 64-bit system in future. So there's all kind of joined up thinking. There's no throwaway work that you would have to undo. If you changed when the strong arm came out to use caller SWI, that translates very naturally to the equivalent in a 64-bit system. And what we definitely don't want to do is to take the tens of thousands of lines of assembler that currently exist in the RISCOS source tree and translate all those faithfully into some 64-bit assembler, because then all we've got is twice as much assembler as we started with. So yes, it would run on a 64-bit system, sure, that you would gain in that sense, but yes, we're now having to maintain twice as much assembler as we did previously, so that doesn't seem a sensible way to approach this. But by moving to writing things in high-level languages, it does then make the available developers much larger. So if I try and a show of hands of how many people count themselves as assembler wizards in the room here, there's probably 1.5 people that might put their hand up if they were feeling brave. Whereas if you see how many people can write C in the world, there's hundreds of thousands of C developers in the world. So it's a much lower barrier to entry if you're wanting to get people to come and help work on RISCOS. If you don't say to them, you need to be an assembler wizard in order to get into the club. So writing things in high-level languages is great for that. And an easy example for that is a couple of people I'm aware of have tried adding some features to BBC Basic, and it's such a difficult task to work out how the flow of the existing interpreter works. It's almost impossible to add any new features, whereas once it's in a higher level language, adding a new feature becomes a lot simpler task. So firstly, a quick thank you if we move on to the money part of this. There have been, when I checked yesterday, there were 79 donations already, which corresponds to about £7,000. And I should add that between now and the 20th of June, so for the next 1 month and 2 weeks, we have an anonymous benefactor who will match up to £4,000 worth of donations. So if there's anyone who wants to put in a few 10, 20 euros, it will become 20 or 40 euros. So it's kind of double the impact for no cost to you. We're also looking, in order to try and boost this, at applying for a variety of technology grants. Those again are a much higher, it's like another factor of 10 size amount of money that you can apply for. So typically they'll be in the tens of thousands, hundreds of thousands of euros. And then if we get to a point where there is a tax issue, if money is sitting in RISCOS Open's bank account, because RISCOS Open is currently a limited company, if you leave a lot of money sitting in a bank account, then at the end of the tax year, the taxman takes 20% of it back off you in corporation tax. So when that becomes a problem, the idea is to set up a charitable foundation that ring fences the moonshot money so that we don't lose it to the taxman every year. It's all totally legal, don't worry. But it avoids having to try and spend money before you get to the end of a financial year every year. So I think this is the last slide. The idea here is that if you look at the moonshots, you might think, oh, that just looks like you're just running another bounty. Why is this why are you not just dealing with this as a bounty? And the key difference here between the bounties and the moonshots is that the bounties tend to be taken on by a developer who is working on it sort of as a favour over a few weekends, and then they'll stop working on it for a bit because their full-time job is taking over again, and then they'll do another couple of weekends, which tends to mean things take an awful lot of time to complete. And the paint bounty is a good example of that. I think that's been worked on for 4 or 5 years, something like that, and it's not yet complete. So the idea with the moonshot is to be able to commission work as a full-time employee, getting someone to come and work on it full time, so that when the project plan says this is going to take 6 weeks, you actually get something after 6 weeks and not 6 weeks worth of weekends, which is 30 weekend, nearly a year. So that's one of the key difference between those two. And so that's why the amounts of money are correspondingly larger than the equivalent that it would have been as a bounty. So there's a couple of near-term ones that we've got eyed up, and that's to rewrite the display manager in C. And that's, although not a crucial module for RISCOS, it's actually quite a small one. It's around 1,000 lines of assembler, so it's the sort of thing that you can write in a couple of weeks. And then the key thing is that because we want, although we don't yet have a 64-bit OS to run it on, it is still something that is useful even on RISCOS 5, normal 32-bit RISCOS 5. So if we add, for example, the feature to add hot swapping of monitors so that it dynamically reads whenever you plug in a projector or something, it resizes everything automatically. That's an example of where you can get a new benefit today on RISCOS 5, and then the long-term benefit is that it's now written in C, so you can use it on a future 64-bit OS. And then Steve was talking earlier today about rewriting the basic interpreter in a high-level language, and that's of the order of £25,000 according to the project plan. And an example of an advantage that you get straight away is the ability to have 64-bit sized integer variables. So even though, again, it's not yet running on a 64-bit operating system, you get the advantage that you can now have variables that are much larger or can calculate a much larger range of numbers. And then another example would be if you wanted to, thinking back to the features that people have tried to add to BBC Basic and not understood it enough to be able to do so, is adding structure support so that you can have dots between members and arrange things that more naturally map to, for example, if you're trying to open a window in RISCOS at the moment, you have to dim a block of memory and then poke a lot of values into it. So instead, if you could define what a window structure looks like, you could then much more naturally write it in BASIC. I think, this is the last slide. I'm 9 minutes over, apologies for that. So yes, what are the main aims here for RISCOS Open? What we're trying to get to here is that option 4 that we saw earlier, where we're running natively on both 32-bit, all the ARMs that we currently have, the Raspberry Pis that we currently have, and 64-bit, the 64-bit ARM cores in the future. And the key word there is natively, rather than running it under some emulation system. One that also supports running those 32-bit applications for which the source code has been lost. So I'm thinking of Eureka, the spreadsheet. It's always a favourite one that sadly isn't available even as a 32-bit application. So being able to run those older applications under some kind of emulator. Getting rid of as much of the handcrafted assembler code as possible and using a high-level language instead. And we're thinking, at the moment, the ratio is something like 40% of RISCOS is written in C, 60% is written in assembler. We're probably expecting the ratio to change to something like 95% written in a high-level language, and then there'll still be a few bits of assembler, for example, to do with memory management that you can't naturally have written in C, but those will still be written in assembler, but it's a lot more maintainable set of source code. And then taking the opportunity to fix up some of the problems that RISCOS suffers from today, particularly to do with security, memory process protection. So if an application crashes, it probably shouldn't take down the whole OS. And being able to use 64-bit address space. So already you can buy an 8GB Raspberry Pi, and that's already larger than 2 to the power of 32. So current hardware that you can buy for 40 or 50 euros already can't access its full address space. And then being able to self-host the tools, so it's nice to be able to both debug and build RISCOS on itself. I don't think it doesn't reflect well of a platform if the only way of developing for it is you have to go and get some other operating system before you can start work. So I would never want to get to a situation where you had to build RISCOS on Windows and that was the only way to generate a ROM image. That somehow feels alien. So that was a summary of where the moonshot activity is. I think I've run out of slides, and I know I've run out of time, but I don't know whether there's either you can come and ask myself and Steve questions directly, or if you can, yeah, I can try and answer questions.
I missed the part of the slide resizing the desktop.
Yes.
Did I pay enough of that?
No, I probably just I skipped over that because I figured you probably were starting to read it. Yes, so at the moment you can change the fonts that the window manager uses to do all the title bars and the graphics and so on. But we discovered that if you try and increase that, after only a few pixels of increase, you start to run out of space on, for example, the title bar, and the text doesn't fit anymore. So although it looks tempting that the window manager says, yes, you can set the WIMP dollar font size to be 25 point, it doesn't actually work. You can go from 9 points to 13 points, and that's about the only limit you can get. So yes, it was being able to more graceful.
Windows, I have control with the wheel, and I have a bigger screen.
Yes, exactly. Yes, so I don't think it would be quite that fluid,
Something
but
like that.
being able to configure it so that all of your tool sprites become a bit bigger, and the font they used for the title bars gets bigger. Yes, that was what that meant. Yeah.
That has my phone.
Yeah, so these are all things that are
Something like that.
aiming for 5.32. If they turn out to be really difficult, maybe they're 5.34.
Well, it would be nice. My eyes get it.
Yes, I find myself. Steve's got a 4K monitor on his laptop. Steve's screen is the same size, but it's 4K. So all the pixels are absolutely tiny. I can't read his laptop, it's too small. Yeah. Oh.
Then question. Suppose next Monday ARM will say, well, all this 64 bits trouble, we'll leave it what it is. We have a next processor, it's 128 bits, that's the future, forget all these things, sorry for you, all your engineers. So what is the consequence for Moonshot? Moonshot 2, or can we seamlessly transfer to compile the things we have in Moonshot, call it Moonshot 1?
Yes. Yeah, so the idea is once you have got it into a high-level language representation, into C, for example, then yes, in principle, you can recompile it for any future core. Someone could even recompile it to run on a RISC-V processor, for example. So it doesn't... ARM is the natural home of RISC-OS, certainly, but once you've got it in a high-level language, it does become a lot more portable. The difference that, particularly in your example that you've given, where it's 64-bit memory space, 128-bit memory space, is all of the pointers would then become twice as long, and that's one of the key difficulties of getting from a 32-bit system to a 64-bit system, is all of the pointers have now changed to be twice as large, and there's quite a few places. If you go to that web link that I showed earlier, there's a big long technical list of all of the SWIs where the pointer is assumed to be 32-bit and can't be changed currently. So those would all need to be revisited if there was ever a 128-bit system, because we've...
So that's where you feel the pain of this 5% trouble left.
Yes, yeah. The most pain, just translating from assembler into C, essentially gets you no new functionality, unless you add some at the same time as we're planning to do. But yeah, if you were to just do a literal translation, you would then compile the C back into 32-bit code, and no one would notice any different. The difficult bit when going from a 32-bit memory space where you have only 4 gigabytes of RAM to suddenly a 64-bit memory space where you have terabytes and terabytes of memory is all the pointers change to be twice as long, and that's particularly difficult if you're thinking of in the window manager. There are lots of places where there's a pointer to a validation string or a pointer to a sprite, and all of those at the moment are hardwired to be only 32-bit. There's only space for a 32-bit pointer there. So yes, those all become much more difficult. And that was the reason for leaving. If you leave the door open, where is it? This option 5, where you do the hard work to get to the 64-bit system, but maybe for applications, for example, you could pretend applications only ever live in the bottom 4 gigabytes of RAM, and therefore all those window manager window definitions you can just leave alone, and then you run the rest of the OS above 4 gigabytes. So that it's a way of breaking it into 2 further smaller steps if you need to. Yes. Yeah. Yeah.
One last question, maybe? Right, I do have one.
Yeah.
There is something like COP, CRMS, created by Julie Stem
Yes.
a couple of years ago already, I think. If RISCOS is converted into basically a higher level language, is the plan to incorporate those developments already?
Yes. So.
Somebody else does something similar.
Yes, I know that Julie. Yes, so Julie had been working on the replacement RAMFS, and she found some. It was either performance or some other fundamental problem that meant she's parked that. I think it's marked as draft now on GitLab. So I'm not sure whether she plans to come back to it and figure out what it was that was the problem. I don't think there's anything unusual about Obey. I think that's probably just waiting for someone to have enough time to understand the changes and merge them, rather than that there's anything technical. I think Obey was technically complete and just waiting for someone. RAMFS, I think, hit some technical problem that meant that she couldn't proceed. Yeah.
Okay, thank you very much.
Oh, thank you. Yeah. If you think of any questions, come and see me or Steve, or go and ask Steve the hard questions.